Good morning to all of you. Myself, Professor N.V. Adpe from SND College of Engineering and Research Center, Evra. Now, today we will discuss about the course of electrical measurement and instrumentation. Now, today we will discuss or start the next topic, that is measurement of energy. Measurement of energy. What is the energy in an electrical system? The energy, which is the actual energy consumed by the load, means it is the product of power and time. It is the product of power and time, and the unit of energy, that is watt hour or kilowatt hour or megawatt hour. But in India, the standard unit of energy, that is your kWh, means kilowatt hour. This will be used for measurement of energy in a distribution system, distribution, transmission, and generating system. This will be also called as the unit of energy, means kilowatt hour. Now the course outcome of that subject, these unit measurement of energy fulfill the course outcome, that is explain construction working principle of single phase and three phase static energy meter and calibration procedure. Means in that unit we have studied the you will study the construction working principle of single phase and three phase induction type energy meter, also calibration process of energy meter. The syllabus of this measurement of energy, in that construction working principle, torque equation of single phase conventional in induction type energy meter, block diagram and operation of single phase and three phase static energy meter, calibration of static energy meter, and TOD meter, that is time of day meter. The energy meter, the definition of energy meter, the meter which is used for measuring the energy utilized by the electrical load is known as energy meter. Means the energy which is used at home, uh, that is energy meter, which is used for measuring the energy which is utilized by the electrical load. Suppose one energy meter is connected outside the home, and this energy meter measures the energy consumed by the load, electrical load, which is available in the home, in that home. The energy is the total power consumed and utilized by the load at a particular internal interval of time. Means suppose we measure the total power consumed by the load. Suppose fan, we take a one fan that is having a rating of 400 watt, and this will be used for the 3 hours. For the 3 hours, means in that the total power consumed by that fan is 400 into 3, that is 1200 watt. But this will be converted into kilowatt hour. This means 1.2 kWh, means the 1.2 kWh energy which will be consumed by that fan. It is used in a domestic and industrial AC circuit for measuring the power consumption. The meter is less expensive and accurate. This meter, that is energy meter, is more accurate as compared to other meters. The construction of energy meter. The construction of energy meter, this is an induction type energy meter. In that there are two coils. This is your shunt magnet. there are two magnets, shunt magnet and series magnet. Also, they have two coils. First one is current coil and second is pressure coil. And there is a one spindle, one disc, and there is a one magnet, C-type magnet. This is your total instrument which is used in a induction type energy meter. This shunt type magnet, they have three limbs, and on the central limb of a shunt magnet, we will wound the uh, pressure coil, wound the pressure coil, and on the series magnet, on that series magnet, we wound the or we place the current coil of a energy meter. And there is a one disc which is rotating when the supply is given to the meter. And there is a braking magnet, C-type magnet, which is used to braking the torque or to limit the torque which is produced in a disc. This torque will be produced uh, due to the interaction between the two magnetic field of the current coil and pressure coil. Now we will discuss the construction of energy meter one by one. First, the meter, which will be the construction of meter, which will be divided into four parts. First one is driving system, second one is moving system, third one is braking system, and fourth one is registering system. The driving system, in that the electromagnet is the main component of the driving system. It will be produces the magnetic flux. It is the temporary magnet which is excited by the current flowing through the coil. Means the current flowing through the pressure coil as well as current coil. Due to that, the core of the electromagnet is made up of silicon steel lamination. The driving system has two electromagnets, that is upper and lower. This is also called as shunt electromagnet and series electromagnet. The upper one is called as shunt electromagnet and the lower one, it is called as, this is your series electromagnet and this is your shunt electromagnet. The series electromagnet is excited by the load current which will be flowing through the current coil. It will be flowing through that current coil, and the coil of the shunt electromagnet is directly connected across the supply. Connected across the supply. Hence, carry the current proportional to the shunt voltage. This coil is called as pressure coil. The center limb of the magnet has the copper band. Has copper band. These are the copper shielding band. These bands are adjustable. The main function of copper band is to align the flux produced by the shunt magnet in such a way that it is exactly proportional to the supplied voltage. It is perpendicular to the supply voltage. This will be adjusted. Suppose supply voltage is in that direction, then the copper shield, it will be in perpendicular to supply system. Second one is moving system. Moving system, in that we use the aluminum disc. Aluminum disc. Moving system is in that aluminum disc mounted on the shaft of the alloy. The disc is placed in the air gap between the two electromagnets. This disc, which will be placed in a two electromagnets, the eddy current is induced in the disc because the change of the magnetic field. This eddy current is cut by the magnetic flux, and the the interaction between the flux and the disc induces the deflecting torque. The eddy current which will be produced by the flux means in that the interaction between the two winding flux, two magnetic flux, due to that the force will be produced on in the disc or torque will be produced in the disc. When the disc devices consume power, the aluminum disc starts rotating, and after some number of rotation, the disc displays the unit used by the load. The number of rotation of the disc is counted by counted at particular interval of time. Means after some interval, the number of rotations of the disc should be counted. And the disc measures the power consumption in kilowatt hour. The meter or the disc measures the power consumed in a kilowatt hour. Next, braking system. These are the braking magnets, C-type magnet. This is called as braking system. The permanent magnet is used for reducing the rotation of the aluminum disc. As the aluminum disc induces the eddy current because of their rotation, the eddy current cuts the magnetic flux of the permanent magnet and hence produces the braking torque. Means the aluminum disc should be produces eddy current and this will be cut the magnetic flux or the magnetic field produced by the magnet, permanent magnet, that is braking magnet, and due to this the braking torque will be produced. This braking torque opposes the movement of the disc, thus reduces their speed. The permanent magnet is adjustable, due to which the braking torque is adjusted by shifting the magnet to the other radial position. Means as this magnet should be flexible as we require the higher magnet braking system, then it will be close to the disc, and if we require less braking torque, then it will be away from the disc. Next one is last one, registration system. The main function of the registration or counting mechanism is to record the number of rotations of the aluminum disc. Means in that we rotate measure the or to count the number of rotations of the aluminum disc. Their rotation is directly proportional to the energy consumed by the load in kilowatt hour. Means the rotation of disc is transmitted to the pointers of the different dial for recording the different reading. The reading in kilowatt hour is obtained by multiplying the number of rotation of the disc with the meter constant. The figure of the dial is shown below. Means as the number of rotation is increased, means in that we count the number of rotation by the counter, and this will be multiplied with the meter constant, that is rotations per kilowatt hour, and according to that this will be convert and show the unit on the screen. The working of the energy meter. Next topic. The energy meter has the aluminum disc whose rotation determines the power consumed of the load. But this disc is placed in between the air gap of the series and shunt magnet. And the shunt magnet has the pressure hold the pressure coil, and the series magnet hold the current coil. The pressure coil creates the magnetic field because of the supply voltage, and current coil produces the magnetic field because of their current flowing to that current coil. The field induced by the voltage coil is lagging by 90 degree on the magnetic field of the current coil because of eddy current induced in the DC. Means as the phase difference between the series and shunt magnet uh, plug, due to that the eddy current will be produced in the DC. The interaction of the eddy current and magnetic field causes torque, which exerts a force on the disc, and then due to this, the disc starts rotating. But the force, this force means this force on the disc, which is proportional to the current and voltage of the coil. The permanent magnet controls their rotation. That is, braking magnet, which will be used to controlling the rotation, controlling the speed of the rotation. The permanent magnet opposes the movement of the disc and equalizes it on the power consumption. The cyclometer which is used for count the rotation of disc, and this will be display on the this will be show on the disc. This is the construction and working of single phase induction type energy. Okay, so stop here. Thank you.